This is a problem on circular permutation. In how many ways can 3 men and 3 women be seated at a round table such that no 2 men sit together? Now, let's solve this problem together. Let's call the women as W sub 1, W sub 2, and W sub 3, and the men as M sub 1, M sub 2, and M sub 3. Let's set aside the men and let's take care of the women. Let's put in a fixed position the first woman, and let's distribute the second and the third women. That is one permutation of the 3 women. Then let's swap the position of W sub 2 and W sub 3. That is the second permutation of the 3 women. So as of now, for the women, there are 2 possible permutations, and we can solve this using the formula for circular permutation n minus 1 factorial. So here, n is 3 because there are 3 women, minus 1, that gives us 2, and copy the factorial notation. So 2 factorial is 2 times 1, or 2. So there are 2 permutations of the 3 women in this circular table. Now let's bring in the men. If M sub 1 is here, we can put M sub 2 and M sub 3 here, and that is one permutation for men. Then we can swap the places of M sub 2 and M sub 3. That is the second permutation for the men. Then we can put M sub 2 in this fixed position and the other 2 in this position. That is the third. Or we can swap M sub 1 and M sub 3. That is the fourth permutation for the men. Then we can put M sub 3 here, M sub 2 and M sub 1 in these positions. That is the fifth. Or we can swap places for M sub 1 and M sub 2 to now have 6 different permutations of the men seated in between the women. And so for the men, notice that we can compute that 6 using the formula 3 factorial, which is 3 times 2 times 1 equals 6. Now you might be asking, why is it that there are 2 different formulas for the women and the men, and both of them are seated around this table? The reason is because for the women, if we move the women counterclockwise, let's say this W sub 1 is here, this W sub 3 is here, and this W sub 2 is there, we still have the same permutation around table. Since they are in a circular table, then we will remove all those other permutations. That is the result of just moving the women clockwise or counterclockwise around the table. And what's left are these only 2 possible permutations. In this case, the clockwise and the counterclockwise permutation of the women are counted differently. But for the men, once M sub 3 is here, for example, if you move M sub 3 to this position, he is no longer in between W sub 1 and W sub 2. Therefore, moving M sub 3 clockwise direction will result in a different permutation because W sub 1 and W sub 3 are different than W sub 1 and W sub 2. And so here, the men are just using the regular formula for permutation, n permuted r at a time, where r is equal to n. And therefore, this is just equal to n factorial. So, what is now our answer to this question? Going back to the concept called the fundamental principle of counting, we now say that if an event can occur in n different ways, and another event can occur in n different ways, then the total number of occurrences of the events is m times n. So in here, the first event can happen in 2 ways, and the second event can happen in 6 ways. Therefore, the total number of occurrences for these men and women to sit around this round table is now computed as 2 times 6 equals 12, following the fundamental principle of counting. So, for our final answer, there are 12 different ways for 3 men and 3 women to be seated at a round table in such a way that no 2 men sit together. And this is now our final answer.